Okay, these are really important problems. BC people, I just worked out one kind of similar to this on the AB test, to the 2004 AB number 5. If you even wanted to just watch that video to see a little more explanation on these concepts, that's a pretty good video right there. But here we go with another one, all right? They give us the graph of f, and they give us this notation where g is the integral of f. And so if g is the integral of f, that means g prime is equal to f, all right? So the derivative of the integral is just that inside function. So g prime is equal to f, which means g double prime is equal to f prime. So we'll be using that throughout this problem. When it tells me to find g of 2, just like if I give you g of x equals 4x plus 5, when I say find g of 2, you just take the 2 and you plug it in for x, right, into your g equation. So all I got to do is take this 2, plug it in for this x right here. So g of 2 is the integral between 1 and 2 of our f of t. Now, because that, and in between 1 and 2, that's the area of this f graph. In between 1 and 2, remember, integral is area. So it's in between 1 and 2, that's this little bitty triangle right here. That, since that is below the x-axis, I could do the area, but I have to, when I'm doing the integral, since that graph is below the x-axis, the integral answer will be negative. So I put that negative in there right away, so I didn't forget. Sometimes I won't do that. I'll just get the 1/4 and I'll just make it negative since it's below. But since I noticed it was below the x-axis, I stuck the negative in there right away. I did the area of this triangle, 1/2 times the base times the height. So 1/2 times 1 times 1/2, get me a negative 1/4 right there. Now, usually, sometimes if it looks like it's going to be 1 or 2, you could probably assume that. You're probably safe assuming that's going to be 2 comma 1/2 right there. But you could also use the slopes to double check yourself. Like if we went down 1 over 2, that's the same thing as going like down 1/2 over 1, and that's going to get you that point. Or you can find your slope, do your point slope form, get the equation of that line, and if I take 2 and plug it into the equation of the line, I do get that y value is negative 1/2, which means the height of that triangle is certainly going to be the 1/2 right there if you're ever not sure. But we're just going to integral's area, right, do the negative 1/4, and then we're done there. Now, when you do g of negative 2, you're going to do the same thing. We're going to take negative 2, plug it in for this x right here. So that's going to be the integral between 1 and negative 2. Now, anytime it's not least to greatest like that, you need to flip those two numbers and make it least to greatest. So from negative 2 to 1. Now, whenever you flip the numbers, then that makes that negative. You got to switch the sign of integral when you switch those two numbers. So you flip the numbers, put the negative right there. And then this is the area in between negative 2 and 1. Now, in between negative 2 and 1, you got a part above, part below. Again, so that negative is only there just because I switched the numbers. So I carry that negative over. Now I'm going to do the area between negative 2 and 1. So I have this triangle here. That's 1/2 times 1 times 3. That's the triangle part. And then I'm going to subtract out this part here in between all the way up to 1 is what we're going to. And then since this graph goes below the x-axis, we need to subtract it out. That's a semicircle, pi r squared divided by 2. So the radius is 1, so pi times the 1 squared divided by 2. That gave me that. And I got that negative 3 plus pi divided by 2 right there. So for part A, you're just plugging those in, knowing integral is area, being careful with your arithmetic right there. Okay, now letter B just says find g prime of negative 3 and g double prime of negative 3. And then remember what we're using over here. G prime is equal to f, g double prime is equal to f prime. So if I want g prime of negative 3, g prime is equal to f. So g prime of negative 3 is the same thing as f of negative 3. And this is my f graph. So I just want to know when the x is equal to negative 3, what's the y value right there? So you can kind of use a slope idea, or if you want to find the slope between those 2 points, find the equation of this line real quick. And when you plug in negative 3, you do get 2 for that y value. But usually when it looks that close to it, like it is going to be that. So we're going to get this 2 right here. And so then that's how we're going to get that answer. All right. And then when you do g double prime is equal to f prime. So g double prime of negative 3 is equivalent to f prime of negative 3. And then so they don't give us the graph of f prime, they give us the graph of f. So to get from f to f prime, that's the derivative, and we know the derivative is slope. So I'm just looking at what's the slope of that f graph at x equals negative 3, and I already calculated that slope right there when I double checked that equation. So that slope was equal to 1, and there's my answer right there. Okay, now part C and D. I really like these problems now, just the way I'm teaching them, the way I'm looking at them. I used to get bogged down with all these charts and stuff like this, but I'm looking at those the right way. It's just more succinct, more compact this way, right? Now, it's asking first, where does G have a horizontal tangent line? Horizontal tangent line is where the derivative is equal to 0. So I jotted that down for myself. G has a horizontal tangent line where G prime is equal to 0. But we know G prime is equal to F. So wherever G prime is equal to 0, that's the same thing as asking where is F equal to 0. And they give us the F graph. So you're looking at where are the zeros of that F graph. Where does that F graph cross the x-axis? And that's at -1 and a +1. So they wanted both of those answers first. And then after you get those answers, they say for each of these values, so for each one, you have to classify that point as either a relative max or a relative min or neither. Now remember, G prime is equal to F. So this is the graph of F. That's the same thing as G prime. This is my G prime equation right here. And so if I want to know G prime has a max, G prime has a max if, I'm sorry, G has a max if G prime changes from positive to negative. That's where the G prime graph changes from above to below the x-axis. So see at x equals -1, this graph of F, which is the derivative of G, changes from above to below. So G prime changes from positive to negative, which that's why I stress that G has a relative max at x equals -1, since the G prime graph, which is your F graph, changes from positive to negative. It went from above to below the x-axis. And that x equals 1, the G prime didn't go from below to above, okay? It stayed negative on each side of that. So F stayed negative, which means G prime stayed negative. That derivative did not change sign. So you had to classify that neither at x equals 1, since that G prime equals F doesn't change sign. It stays negative on both sides. Had this graph gone from below to above and actually crossed over, that would have been a relative min, since the G prime equals F changes from negative to positive right there. So like I said, on the 2004 test number 5, I explained those concepts in pretty good detail as well. And you got the max and mins in there, and you got the inflection points in there. So just, if it's still a little fuzzy, watch a couple of the videos. Don't just watch one, watch a few of the videos over that stuff there, and then you'll be happy with that. All right, the last problem then, where does G have an inflection point? We always look at the second derivative for that. So I I talk myself into getting the right answer here. G has an inflection point where the G double prime changes sign. And G double prime is equal to F prime. So that's the same thing as me asking myself, where does F prime change sign? And they give me the graph of F. So to go from F to F prime, that's the derivative of F, which is the slope of F, because the derivative is slope. So I'm asking, that's the same thing as me asking myself, where is the slope of that F graph change sign? Whenever you want to know where a slope changes sign, that's where that given graph changes direction. Because think I have a positive slope and I have a negative slope, that's where that graph changed direction right there. So that's where I'm looking at to get my answers. Where does it change from going up to going down, or going down to going up, from increasing and decreasing, or decreasing and increasing? So right here, it goes up and goes down. X equals -2 is 1. Then it goes down, keeps going down. Then be careful right here. It goes down and goes up. So x equals 0 is 1. And then it goes up and goes back down. So the slopes change sign. So at x equals 1 is another one. So those are my 3 answers. And I just like to just summarize that. I said G has inflection points at the x equals -2, 0, and 1, since the G double prime equals F prime changes sign right there. And that's the slope of that F graph right there. So try to look at this problem and then go back and watch the other video if it's still a little bit fuzzy. I feel pretty confident that other video might make a little bit more sense than this one there, and just merge all that stuff together and get better and better at those. Waffles.